Hi there. Thank you for clicking on this video. This video lesson is going to take us through using the discriminant in solving quadratic equations and determining what kinds of answers we have. Please like and subscribe if you find this video helpful. Drop a comment or question below and check out the other videos and playlists on the channel for more math help. Now, before we begin, I'm going to try to link this in a card on the screen here. Check out the short video on types of real numbers before going further. Make sure you know the difference between rational and irrational numbers. So if I'm using those words and you are 100% confident that you could give a good functional definition of rational and irrational numbers, then proceed. But if you're not sure what they are, there's a quick 3-minute video linked above that'll take you through a quick definition and some examples of what they are, because you're going to want those vocabulary words before moving on. Now, when solving a quadratic, using the quadratic formula, there are 4 things that could happen in terms of the types of answers we get. So in this lesson, I'm going to go through and work the problems out all the way to completion so that we can see the types of answers. But what we're aiming for here is being able to identify the kind of answer that we're going to get without having to work the whole problem out. Okay, so the discriminant is intended to be a little bit of a shortcut where you can say something about what the answer will be without having to go all the way to the answer. So that's where we're going with this. Now we'll look at case 1. Case 1 is when you have 2 real rational answers. Okay, so you can get 2 answers and those answers are going to be rational. So again, what we're looking at here is how many answers am I going to get? In this case 2, and what kind of numbers will they be? They will be rational. So let's take a look at this. We've got in this problem, A is equal to 2, B is equal to 5, and C is equal to -3. And we're going to go ahead and dump those into the quadratic formula. Okay, which if you're not comfortable with this, please go check out the video on the quadratic formula. Now, the part of the quadratic formula that we're going to focus on is this part right here, the b squared minus 4ac, because this is the part that determines what kinds of answers we're going to get. Now, again, I'm going to work the entire problem out, but I want you to be paying close attention to what happens here. So plugging in our numbers, we have the opposite of b. Well, b is 5, so the opposite of 5 is -5, plus or minus the square root of, and I always encourage students to put a parenthesis around that 5. It just causes problems sometimes if you don't. -4 times 2 times -3, all over 2 times 2. Okay, now let's take a look here. We're going to have under the square root, 5 squared is 25. And then it might help you, I do this all the time in my videos, to remember that that minus sign is plus a negative. So what you got going on there is -4 times 2 times -3, which is going to be positive 49. Sorry, positive 24, which will add up to 49. I'm like one step ahead of myself in my head there. So here's where the 49 is. Like, I promise I'm not losing my mind. I mean, sometimes I think I am, but I was like one step ahead in my head there. I was like 49. Okay, and what you want to notice here is that taking the square root of 49 does give us a rational number. There gives us an integer, it gives us the number 7. And so we're able to take the simplification further. So we have -5 plus 7 over 4, and we'll have -5 minus 7 over 4. -5 plus 7 is 2. And 2 over 4 is 1/2. And then this, again, might be helpful to just think of that as plus a negative. So you're going to have -5 plus -7, which is -12. And -12 divided by 4 is -3. So notice that we've got 2 numbers and they are rational. Okay, so they're 2 real numbers and they are both able to be written as fractions. And what I want you to notice is that the number under the square root is a perfect square. So we ended up with the square root of 49, so that when we took the square root went away, and we ended up with a number that we had to both add and subtract to get our answer. And the fact that we had to add it to get one answer and subtract it to get the other answer is what gave us the two answers. And what gave us the rational answer is the fact that when we took the square root was no longer there. Okay, so notice that the number under the square root was a perfect square. Let's take a look at case 2. This is one real rational answer. Okay, so we want to look at what is going to happen here. So we have, in this case, a is equal to 1, b is equal to -8, and c is equal to 16. And we're going to dump that into the quadratic formula. So the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And once again, please make sure that you're paying attention to this piece right here. So we'll start with the opposite of b. In this case, b is -8. So the opposite of -8 would be +8. And then we're going to do b squared. And again, you definitely want to have the parentheses there because now it will cause a problem. Minus 4 times 1 times 16 all over 2 times 1. And looking at what's under the square root there, -8 times -8 will give me +64, and 4 times 1 times 16 is also 64, so we're going to have 64 minus 64. 2 times 1 is 2, and 64 minus 64 is 0. The square root of 0 is 0. And what you want to notice here is that if I do 8 plus 0, okay, I mean, we could carry this out just so you can see it. If you do 8 plus 0, okay, or you do 8 minus 0, that lands you in exactly the same spot because 8 plus 0 is 8, and 8 divided by 2 is 4, and 8 minus 0 is 8, and 8 divided by 2 is 4. And so this gives us one answer. Now, it is not irrelevant to note that that answer comes up twice, okay, once with the adding and once with the subtracting. But if you think about the number line, there's only one 4 on the number line. So if you're going to like plot where your answers were or look for your x-intercepts, it's not like there's 2 4s somewhere that you can make, only one 4. So we get one answer, and that answer is rational. So note that the number under the square root is 0, okay? And the square root of 0 is 0. So the fact that when you take the square root of 0, the square root goes away, that's what makes it rational, because you no longer have the square root in there. And what gives us one answer is the fact that it's 0, and adding and subtracting is 0 just lands you in the same place. Now, it lands you in the same place twice, but it does land you in the same place. All right, now let's look at case 3. Now in 3, we're going to go back to having 2 answers, but now those 2 answers are going to be irrational. So we're going to, let's go ahead with this. So we have a is equal to 1, b is equal to -4, and c is equal to -2. And we'll copy down our formula, the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. The opposite of b, well, b is -4, so the opposite of -4 would be +4. Plus or minus the square root of, please make sure you have your -4 squared there, okay? It will not go well if you don't. -4 times 1 times -2 all over 2 times 1. And all right. Under that square root, -4 times -4 is +16, and it might help you to do plus the negative, okay? So you remember that that is -4 times 1 times -2, which is going to give you a +8. So I see lots and lots and lots of sign errors with the minus and the negatives thrown in there. 2 times 1 is 2. And then we have 4 plus or minus the square root of 24 over 2. Now, here we're going to have to engage some of our skills at simplifying square roots. So 24, you can factor that however you want. I'm going to go ahead and factor it into 3 times 8, and 8 factors into 4 times 2, and 4 factors into 2 times 2. And so the prime factorization of 24 is 3 times 2 times 2 times 2. So we have 4 plus or minus the square root of 3 times 2 times 2 times 2 all over 2. And we are looking for perfect squares. So I'll notice that I've got the 2 squared there, okay? And the square root of 2 squared would give me 2. So we have 4 plus or minus 2, and then under the square root, you still have the 3 times 2. So that'll be a 6. And we can do a little bit more simplification here because we can actually split that up. So that will be 4 over 2 plus or minus 2 root 6 over 2. 4 over 2 is 2. And then 2 divided by 2 is 1, leaving me with just the root 6. Okay, and what we want to notice here is that we do have 2 answers. So if you're like, well, I only see 1 answer there, what are you talking about? One of the answers is 2 plus root 6. The other answer is 2 minus root 6. And so those are the 2 answers. So we have 2 answers. They are real and they are irrational because the square root of 6 is an irrational number. So you're going to take a 2 and then you're going to add to or subtract to it some number that is a decimal that never ends and never repeats, and so you're going to end up with that irrational number. Now, what I want you to notice about that is that the number under the square root is not a perfect square. So if you get a number like 24 that does not take a square root nicely, then you end up with a square root in your answer, in this case, the root 6, and that means your answer is going to be irrational. So again, always like kind of focusing on what is the number under the square root, because that's the one that drives the ship here. The b value outside and the number in the denominator, those are always going to be like real and able to be written as a fraction because they're like already as a fraction. It's the piece under the square root that is determining what's going on. All right, now the last one, this one, I just want to make sure that I address this with you. This is when you have no real answers. So on this problem, we have a is equal to 1, b is equal to 4, and c is equal to 10. So the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. The opposite of b, well, b is 4, so the opposite of 4 is negative 4. Plus or minus the square root of, now technically the 4 does not need to be in parentheses, but if you're in the habit of doing it, you'll not forget it when you need it. So we have minus 4 times 1 times 10 all over 2 times 1. And 4 squared is 16 minus 4 times 1 times 10 is 40 over 2 times 1, which is 2. And then 16 minus 20 or minus 40, or 16 minus or plus negative 20 will give us negative 24. And that's where we come to a standstill, okay? No real number squared can give us a negative 24. So you can spend some time trying to find a number, but remember, like what the square root does, the square root undoes squaring. It asks you what number squared gave us this number, and no real number that we can find on that number line anywhere is going to square and give us a negative 24. So at the Algebra 1 level, you might get away with just saying no solutions. I would encourage you to put in like no real answers or no real solutions, just as a preview. Okay, and if you're watching this video and you're in Algebra 2, then you're either there or you will be. There are answers but they involve kinds of numbers that you don't know at the Algebra 1 level. So typically at Algebra 1, you get that negative on the square root, you say no real answers. So what we want to note there is that the number under the square root is a negative, and that stalls out the problem. There is nothing on the number line that's going to help us out there. So let's summarize what we've gone over. B squared minus 4ac. Throughout this entire lesson, I've been telling you, focus on that number that's under the square root, b squared minus 4ac. The name for that expression is called the discriminant. Okay, that's, if somebody talks about the discriminant in the quadratic formula, that's what they're talking about. The discriminant can be used to tell us how many and what type of numbers we will get for our equation. In terms of our solutions. So on the left-hand side, I have b squared. Now, if you're not familiar with what I did there, I was typing in a different program that does not do exponents. That little caret is one way of writing an exponent, and you will see that in some calculators. You might see it typed up. It kind of depends on the program that you're using to type. Finding programs that type math well is not super easy. So that is b squared minus 4ac. Now, from the get-go, and typically in my Algebra 2 classes, I would do the negative last, but I'm going to do it first, because if you get a negative, you are immediately going to say no real solutions or no real answers. Okay, and it doesn't matter what kind of a negative you get. It does not matter if the negative is a, like, well, I guess it can't be like a perfect square, but it doesn't matter if your radical would go away or not. And that gets into Algebra 2 stuff. If it's negative, regardless of what other attributes the number might have, there are no real solutions. So, just negative, no real solutions. Now, if the number under the radical, so I'll do the example kind of out to the side here. If the number under the radical is a perfect square, that means when you go to take the square root part is going to go away, and it's going to leave you with some thing that you could add or subtract. And so that's going to give you two real rational solutions. Okay, and that would be like getting the 49. Okay, and so you end up square rooting the 49. Now, if that perfect square number happens to be a 0, okay, then not only do you get rid of the square root, but also the plus and minus become irrelevant. And so that would be one real rational solution. Okay, and that means that you end up doing plus or minus 0, so you get the same answer twice. And if you get something that's not a perfect square, so you get anything that's not a perfect square, the square root is actually not going to go away, and you're going to end up with two real irrational solutions. And we got that when we got the square root of 24, okay? And that simplified into 2 root 6 for us. And so we ended up with that square root that was still sitting in the answer. So sometimes in math, you don't necessarily need to know exactly what the answers are. You just need to know how many answers will this have, and what kind of a number, like will they be rational or not? And there's something that will come up. It'll be the next main thing that we cover in this video series, that if you end up with one of these two, it means that you can do something with that equation that you can't do if it's in this category here. Okay, and so the discriminant can be used to just give us more information about what the answers will look like. Okay, don't forget, like and subscribe if you found the lesson helpful. Drop me a comment or question below. Check out the practice set for this lesson. It'll be linked in the description box, so make sure that you get a chance to practice the material we went over, and check out the other videos and playlists on the channel. I will see you in the next one.